Hello, hello, hello. मेरा वॉइस क्लियर है? वॉइस इज क्लियर. हेलो हेलो. Clear. Okay. Okay. We'll wait for some others to join. Let's wait for them. Like I'm having those VMs for to do based on the work I do. So first one is for general purpose, right? For Linux and all. Second one is for MildLib Academy, if you know, it is about the malware analysis and all. Third one is of Windows 10, which I used for mostly for reverse engineering or some basic tasks which I need to do. Then this one is for expert development. This is also for expert development. Windows 7 just for for testing purposes and all. And Ubuntu for focusing right now on this. Mr. X. Oh. Hello, bro. Hello. Hi. Hi. Okay, yeah. Is my voice clear now? Hello, one, two, three. Hello, hello, hello. Just tell me in the chat section so I can take a look that you all are with me. Mr. So, what's your laptop specification? Yeah, bro. Nothing much. Just Intel i5 level generation. Okay. And 16 GB DDR4 RAM and 500 GB SSD and 1 TB hard disk. That's all. Nothing much big, but we can say from mid range and dedicated graphics card of NVIDIA MX350. You want task manager, I guess. Yeah. You can say it's Intel i5 level generation, memory which is around 16 gigs of RAM, hard disk and SSD one of NVMe to an NVIDIA GeForce MX 350 Ti for maybe gaming some stuff. So this is my system specification. Today we're going to learn some sort of assembly. Okay, we can say assembly. Okay, now I'll just get a folder over here. Assembly. So, how many of y'all know about assembly language? Just tell me yes or no. Lab. Okay, the lab setup, right? You mean lab setup? Okay. For reverse engineering, you need to first install uh, operating system which you all want. I use Ubuntu just because it's my favorite one, and I use mostly of these stuffs over here only. So first of all, go on your browser and then download some tools. Okay, there are list of tools which I'll going to show you all. First one is Vidra. Okay, Vidra, this tool one. Okay, so download this tool. For downloading this tool, you all can just type command sudo apt install, or we can say snap install tra, and then it will going to ask you for the password. Okay, so this is the command to install Ghidra on Ubuntu. For Kali Linux it will be pre-installed. Okay, so this is the first tool which we need for reversing. The second tool which we need and that is called as binary ninja. Okay, so this tool is very helpful. Okay, so this tool one, so you all also need to download this tool, the free one. Click on free version and download it for Linux. Okay, so I'll just show you, and you can see that the download has been started over here. Okay, uh, are you sure? Like, I don't know, but if that's the thing, then you can just type Ghidra over there and hit enter. So now it will going to give you the prompt saying that did you mean to install Ghidra, and then click on Y, or even you can just type apt install Ghidra. It's around like a 1 GB or something files are there. Okay, so just download it, and after that you have to download the binary ninja, the free version. Okay, so this one you have to download. Okay, the zip file, and then you need to go. I'll open one more new terminal over here. To your downloads. Okay. We can see this zip file, right? So there is a command called as unzip, and the name of that particular file which you want to unzip, right? So you can just give the name. But before that, I'll recommend you all to copy this file into a OTP directory, opt directory. Okay, so opt directory is nothing but where you can store your tools. Okay, so go to slash opt over here in this opt directory. Okay, so here you can store all your tools and all the instruction scripts which you are required to, to do that kind of stuff. Okay, so now I'll going to put sudo copy my binary ninja from downloads folder, ninja.zip over here, and paste it over here. So I'll hit the password over here, and it will going to copy the zip file. Now make a directory for bng named as binary ninja. Okay, and then unzip it binary ninja to bng directory. Okay, so you had to just unzip it to the particular directory whichever you want. So I've done it binary ninja short form. Okay, file. Okay, remove the dot, I guess. If you add sudo, just do like this. It will going to extract all the folder named as binary ninja. Okay, so you don't need to make this folder. I'll just remove this rm hyphen rf bnj. So now we can see we are having this folder over here. So I'll go to that particular folder, binary ninja. So now we can see we have already installed this tool. So if you type dot slash binary ninja, we'll see the tool has been launched, and then we can click on start and all. Okay. So further process will be done in further upcoming classes, or even in this video maybe if I get the time. Okay. Now just close this. And now we'll so these are the two main tools which I told you. First one is Gudra, and second one is the binary ninja. Okay, so these are the tools which we need currently to learn reverse engineering, now the thing is that after downloading this, so these are only two tools which we currently require, and the third one is GDB, which we have discussed yesterday, right? The GDB tool, this one. Okay, but even there is one more additional plugin for this GDB which I want you all to download. Okay, the plugin is called as Pwndbg. Okay, so I'll tell you what exactly it is. So this Pond debug is a extension of, or we can say a plugin to a GDB, the utility which we have used yesterday, right? So this GDB is very minimalistic. Okay, so every time if we want to reverse engineer or do something stuff related to memory, every time we need to type the commands like r and then info and all. Okay, but when we try to install this plugin, or we can say, or this utility over the particular GDB, then we get some ton of features like I'll show you. Okay, just a second. So for that, what you all need to do is that after coming to this particular link, okay, so I'll just paste these links in the chat section. uh, this one is the link, first one, and this one is the second one. Okay, what's your methodology for reverse engineering CTFs? Yeah, I'll tell that in yeah, wait, I'll talk about it. So before that, I'll just show you all how to install this Pond debug extension onto your particular system. Okay, first thing, just go to this particular GitHub repository, and then come under the release section over here. Okay, the release section, and then click on this, and then we can go save secret. Hi bro, hi buddy, hello. Okay, so we were just discussing the tools which we require for reverse engineering CTFs and all. Okay, now after going to the release section, come over here and download the particular deb package. Okay, So in my case it was architecture of 64. Okay, and if you all are using the Ryzen processors or AMD, maybe you all can download this dev file. For me it was Intel based, so it was arch64.deb. So you have to download only the deb package. Okay, the deb package, the Debian one. Then after downloading this package, it will come under your downloads folder. Okay, so it will going to come under this download folder over here, this package. Okay, now how will you install this? So for that there is a command called as sudo dpkg -i and then the name of the package. So this will going to install the Pwndbg into your system. Okay, so in my case I've already downloaded or installed that particular system, sorry, the particular tool into my system. So the command will be pwndbg, and we can see this is the interface of Pwndbg. So this is a very good tool, greater than GDB, but actually it is based on GDB only, but with some additional plugins. Okay, so I'll just show you all the yesterday's CTF, right, the one which we did, right, main one. So yesterday what we did, guys, we said GDB and the name of the file, right, this way. So this was the way how I taught you yesterday, but today we're going to use pwndbg and then the name of the file. So this will going to list all the and include some additional plugins and all. Okay, so this will be very helpful for us. So anytime or in for the upcoming videos we're going to use Pwndbg, which is based on GDB only but with some additional plugins and features. Okay, did you all got what I said about Pwndbg and GDB? No worries, bro. The stream has just started. Did you all got Pwndbg and the GDB difference? I hope you all are getting. Got it, got it. Okay, fine, fine. Yeah, perfect, perfect, perfect. Okay. Hello, Vinay. Hello, hello. Hi, hi. Okay, fine. So now, what we're going to do is that I'll just show you all the difference in which we can, see that how useful this pond debug is. So yesterday we have used this simple version of GDB. So today we're going to use pond debug. Okay. So just clear this screen. Now, first command is pwn dbg, the debug file and the name of the file which we want to crack. So and then hit enter, and the first step was info functions to list all the functions. Okay, and then we can do disassemble. Oops, it was disassemble main. Okay, to show the output of the particular main file. So yesterday what we did was that a simple breakpoint to the compare instructions. Okay, over here. So it was breakpoint star main plus compare instruction was at 84 byte. So 84. Hit enter and then click on run. So it will going to prompt me for the password. So I'll say I'll enter a wrong password. And now if I hit enter, we can see uh, the all the content of the registers and the live disassembly view and even some additional data. So that's why pond debug is very useful in such cases, because while debugging we can literally see the each instruction when it gets executed after the breakpoint, and even we can see the contents of rx rda rsi. But in old GDB we used to type commands info registers and all. Okay, so that is why this particular plugin is very helpful, because it also displays the registers, the disassembly, the exact point where the instruction is pointing to, and all the stops which is required over here, the stack pointer, the base pointer, the memory addresses. Okay, so that's why the Pwndbg to the plugin is very useful. Got why it is so useful and it is used. And even we can see on their website over here, exploit development and reverse engineering with GDB made easy. So y'all can got the idea like why is it so useful in terms of this. Got it? Just say yes. So I can, proceed further. Okay. So that's why I recommend using your Pwndbg instead of GDB. So I will just quit this. So now we're going to come to our today's uh, agenda. Okay, by looking at the thumbnail we can say that today we're going to learn the assembly, the programming in assembly, right? So yesterday we have had some basic idea of opcodes, the registers, the difference between 32-bit and 64-bit registers which were of used. Okay, now today we're going to create our own assembly code and we're going to compile it and run it. Okay, so first one will be a very classic one which is called as hello world, right? So in most of the videos we try to in most of the programming languages we try to code as an hello world. Okay, you don't use Windows for reverse engineering. Actually the thing is that when you start the term reverse engineering or when you try to learn reverse engineering, it's better to start from the Linux because it's like very open and all. Okay, and it will give you a very good like point of view like how the things works, and after that we can jump on Windows. But the thing is that there is nothing much difference between Linux and Windows if you're focusing on reverse engineering. There are some but not that. Okay, it depends upon what tool we use. Okay, so today I'm going to create one file called as prgm1.asm, program1.asm. Okay, and I'll hit enter. So we can see we are having a file which is program1.asm. Now I'll open it into a text editor. Okay, oh yeah. Okay, so you all can use your text editor like V, Notepad, okay, or even Sublime Text, Nano, anything stuff. So today I'm using Nano over here. So the syntax which we're going to use will be Intel 80 x86 architecture based. Okay, yes, please like it, like very fast. Yes. Okay, um, so now before writing the hello world code, there are some sort of things which we need to know, and that is this. So just type chromium syscalls. Okay, everyone, just go on Google and type chromium syscall, and then you will go and then you will get the first page. Okay, then you will going to get the first page over here, the chromium os doc linux system call table. So just open this website. Okay, so throughout this content and throughout this video, this website will be very helpful for us. I'll tell you why. After coming to this particular web page over here, we can see the contents, right? So we need to click on the architecture which we need. So in this case we are trying to learn the assembly, right, based on x86, which is a 32-bit assembly. Okay, so we'll just click on this. Let's see the comment. Hello, hi, welcome to my stream. I hope you all are enjoying, right? Now after coming to this, we can see over here the table. So this table is very important in the field of writing programs in assembly. Okay, so this table is very important for us. Okay, now Over here the first one is NR, which is the just a serial numbers. Okay, over here the second column is over here, which is based on syscall name. Third one is references, which we don't need to focus, okay, until now. And the fourth, fifth, sixth, so these are all the contents of the register which we need to note it down. Okay, so you all can just start this page for the bookmark. Okay, yeah. um, Now we need to learn assembly language until there is a ChatGPT is available. Scam होता तो no यार, because yeah, if I turn on my face cam, it will be like more, you know, maybe not that good. It will, my laptop will like, crash. Okay, so now there are some sort of, registers over here. So there are some protocols which we need to fill up before calling the particular syscall instructions. So now what are syscalls? So syscalls are basically the calls which we do call the CPU to perform some set of instructions. Okay, so now when do we call a syscall? So there is an exit syscall over here which will going to terminate the code. There is a read syscall which will going to read the input, read the file, and even there is a close syscall. So there are many syscalls over here: QTime, access, make dir, rename, kill process, set UID, get UID, and then there are many other stuffs going over here. Okay, so these are the syscalls which we need to perform. So today we'll going to display like a hello world. Okay, or like we're going to display a hello world using the write syscall which we use to write a particular, you know uh, string or particular characters onto the console. So we're going to use the write syscall. So now let me be clear. The thing is that this thing might be boring, but the stuffs which I'm teaching today, programming in assembly, is very useful and mostly into the terms of reverse engineering. Because if you all know to write custom codes in assembly and you all can, read it very well and even write it, it will be very helpful for you all only to, disassemble any program, or even find some bugs. Not bugs, maybe like you all can even do very good in CTFs. Okay, we need to learn assembly. Yeah, I yeah, that's the point, because we need to learn it, if you all want to be good into finding CTFs. Okay, and even into the terms of cybersecurity, of reverse engineering, malware analysis. Okay, so and even into the terms of expert development. So if you all know assembly, then you all are like, a great guy. That's all what I can say, because this field is very important, or we can say a very least and a low level language in which we write. Telegram. Yeah, bro. I'll just tag it, or maybe better, I'll just give you my the WhatsApp group, which I know there are all the members over here. I'll just provide you the WhatsApp group. Expert development. Yes, so because expert development is a field in which we try to find some memory corruption bugs. Okay, for an example, buffer overflow, heap overflow, format strings, integer overflow. Okay, so these are some memory corruption bugs which come under the field of reverse engineering, but more deep into that. Okay, so that thing is like totally different, and reverse engineering is different, but the base is same, because we require only assembly for that. Okay, and we need to know to read, write, and even think that how assembly works in the internal memory. I hope you got expert development what I'm trying to say. It They are nothing but they are just a memory corruption box. Okay, from that box we can take remote code execution on the victim's system easily. So in the further videos also, I'm going to bring a series related to exploit development, in which we're going to exploit the buffer overflow, format string, integer overflow, return to libc attacks and all. Which malware which are built from assembly languages will affect the hardware of the PC? Yes, those types of malwares are called the rootkits. The rootkits are like they are very dangerous because once they infect your core system files, and they are mostly written in assembly. Yes, Tuck said you are correct. They are mostly written in assembly so that they get the least power on the particular motherboard, or we can say on the hardware, to access all those stuffs. Yeah. Yeah, we can say the expert development stuffs, but no, but currently it's like not that much we need to focus. But in the further upcoming videos, or even you can go through my channel where I've uploaded, I guess, one video on the buffer overflow. But similarly, I'm going to conduct live sessions on upcoming videos where I'll be going to explaining the buffer overflows and all that kind of stuffs which are related to expert development. Okay, so now coming back to the topic, which assembly is best for malware analysis? The assembly which we use, right? The Intel x86, the Intel assembly. So currently, I know only the Intel assembly. Okay, not the AMD one. The Intel is like very good because of its syntax. Okay, how does it bypass the antivirus? The actual thing is that. They create some memory evasion techniques in which the antiviruses are not aware about. Okay, like there are many techniques of like DLL injection, process injection, then a process hallowing attacks and all. So those types of attacks in which they try to evade the antivirus, or even you can say the EDR. Okay, so basically they try to bypass that particular rules and get the administrator access on the system, so that they can basically bypass the antiviruses and all. Okay, right. So now we'll going to write a hello world code. Okay, so before that we'll come onto our shell. So now first thing first. Okay, what is OSIT? Yeah, it is an certification provided by OffSec. Okay, let me show you all over here. Um, it is a certification provided by OffSec, which is called as Windows Exploit Development, Windows User Mode Exploit Development. So this is similar certificate, but with some advanced, techniques which you all need to know. Okay, so it is totally based on memory corruption bugs. Okay, yeah, correct. So just some, yeah. So this is just a Windows user mode exploit development in which we try to get through all the memory corruption bugs and all format string. So this is just a very tough exam, we can say, conducted by the OffSec security. Okay, yeah. So now we're going to write hello world code, okay, onto the system. So now before writing over there are some sort of rules which we need to define. So first one is the entry point from the where code will going to get start. So this is the syntax for it: start and the colon over here. Okay, then hit enter and then hit tab, or we can even do like this. So this is the syntax for writing the assembly. So first it will be underscore start start, meaning that the compiler will know from where to execute the code. Okay, now we need to write the message, or we can say we need to write hello world. Okay, hello world on my output console using this particular program. So now how will I write it? So to write this we need to store this data. Okay, so we need to store this data into a memory segment. Before that I'll show you all a simple assembly code. Okay, so I'll just say tab move eax. First I'll write a simple code of exit code. Okay, so it will be eax01 opcode, and the exit syscall. So I'll just show you all the simple code in which how we can exit a process. So we can see the syscall name which I want is exit. So before writing on some console, I'll just show you all a simple code to exit. Okay, so syscall name is exit. and the EX register content should be 0x1. Okay, 0x1. Now what I'll do is that I'll go to my terminal and move 0x1 into EAX register, come back and say int 0x80 to make a system call. Now I'll explain how it works. Okay, so just control S, control X, and then type nasm hyphen F. I'll explain this command to you all. Okay, program1.asm hyphen o program1.o. So now over here we can see we need to install a tool called as a NASM. So NASM is an compiler for an assembly language. So like how we use it for like how we use for C++ to code. So we use GCC, right? GCC compiler. On Windows we use MSFE compiler, which is officially provided by the Microsoft to compile it. Okay. Yeah, safe security. Yeah, yeah. So 0x1 is an exit call. So I'll just explain it. So first of all, we need to install this command. Oh, sorry. We need to type this command, which is going to install the NASM compiler onto my system, which is going to compile the assembly code to the object code. Okay. So for that, we need to type this command: sudo apt install NASAM, and then give your password, and then it will going to install it. So I'll just paste this command into the chat. It seems I'll try it, but it's not possible to change in the middle of the stream. It should be not illegal. Okay, after installing this, we'll say the process triggering, and then it will going to say yeah, it has been installed into our system. So now I'll explain this command to you all. So first one is the NASM compiler, which we're going to use. NASM hyphen F stands for the format. Okay, make sure what I'm trying to say to you. Hyphen F means the format in which you need to compile it. So there are basically two modes: 32-bit mode and a 64-bit mode. Okay, so in this particular session we'll going to focus on 32-bit mode, and this is a ELF structure because the output is for the ELF program, right? So we are stating it as ELF32, and then program1.asm, the program which we need to compile. Okay, and the hyphen o stands for the object file which we need to create as prgm1.o. Okay, and then hit enter. So we can see there are no errors or no warnings, nothing. So you can hit ls and see the object file has been created over here. Okay, got it. So after that, what we need to do is that we need to link it. Okay, so we'll just say ld program1.o hyphen o program. I'm getting an error, I guess. I'm getting some error. Oh, I missed something into my assembly code. Just a second. Okay, program1.asm to do some stuff. So here I guess it. Okay. So I forgot you all to explain one more main over here. So the main thing is that you all need to basically add some, you know, a text section. So there are some few sections which I forgot to explain. I'm really sorry for that. There are many sections in memory, okay, which we need to define. Okay, if you are aware about there is a section called as a text section in which the exact code is being stored. Okay, so this is the format we in which we write. So there are many other section called as dot data section and the dot bss segment. Then there are many segments I can show you, I guess. So yeah, text section, data section in c, in sm. So I guess yeah. So there are many other, the sections which are there, like BSS segment, data segment, which stores your, the variable data which are defined into the memory, like x is equal to 10. So int x is equal to 10 will be, storing that particular memory into the dot data segment. Okay, and there are other segment called as, the dot text segment, where your actual code is there. Okay, your where your actual code lies over there. So we can see in this segment, I guess, the code segment is over here. So yeah, so these are all the part of the code segment, and the int b, which I gave you all the example, right? So the data which we store is in the data section, and the data which is not initialized is being stored into the bss segment, which is called as uninitialized data segment. Okay, so compiler should know like what data is being, made, or the like, what function it consists of. And there are some, other sections also, and the whole the section which stores the actual code is called as the dot text section, or we can say even the code, but it is called as the dot text section. Okay, I guess I got a proper view of this. Open image in new tab maybe. Yeah, so this is the thing. Okay, so we can see over here there are some, sections which have been defined over here. So dot tag section will consist of a global start function. Okay, so this is mandatory to write. Okay, this is a rule in assembly to write. Okay, the global underscore start, and then where you need to enter the code which will going to, write, or we can say, will going to print hello world. So that code will going to come under the underscore start, two colons, and over here this will contain the all the instructions code which will be going to write. And the dot data section, the data which we will going to define over here, like int x is equal to 10, 20, 30. Okay, and the dot bss segment, as I told, will going to declare it but not initialize the values over there. Okay, any questions, just ask freely. We are having time today. Okay, just tell me in comment section, did you all got or not, rather than printing hello world. Yeah, yes. Any questions, guys? If you're having really some questions related to the explanation which I gave you all right now. Any questions, then just chat it out. Saying असली मर्द stay. सही बोला तूने भाई. Okay, now we're going to write a code which will going to perform the exit. Okay, before writing some hello world or any kind of stuff, I'm going to show you all the first code which will going to exit, because that will be a easier one. Because if I show you all the directly hello world code, you all will be like, what the hell is going. Okay, right. So now, so coming back over here, for the time where I said section dot text. So the text section where I've declared a global underscore start function. So start function is as same function like a main function in the C program which we use. Okay, so we write start the colon, and from here we try to write all the instructions what we need. So currently I have moved EAX 0x1 value. Okay, so now why? So now this will going to move so this will going to move hex 1, which is the one value, into the EAX registers. One more tip over here for y'all guys. In the C program, we use comments section, like the double colon, or Python we use the hash. In assembly we use comments like the semicolon. Okay, semicolon is just for commenting. So I'll just comment this over here and I'll say loads, or we can say move 0x1 into EAX. Okay, so now, okay, I'll just move. Okay, so this will going to move hex1 value into an EAX register over here. Okay, so this is just a comment. So this instruction performs the move instruction. So the source part and the destination part, as we discussed yesterday. Okay, and after that we are trying to do something called as integer 0x80. So now this is the very crucial part where we need to know why I'm doing this. So this is called as syscall. So this is called as syscall. So can anybody tell like what exactly will it do? Yeah, I'll tell it. I'll tell it. I'll tell it. I'll tell you why. Okay, so we only want 0x80 because it is a software breakpoint which is predefined into the memory processor only. Okay, so if we see the CPU, or we can say int 0x80. So if you see this instruction, it takes the interrupt of a number format of a byte value. So we don't need to focus more into this, but this 0x int 80 we use to exit the code, or we can say just kill the particular software interrupt. Okay, so we just put it as 0x80. So we are just trying to call the CPU over here. So now we can see syscall name right over here, and there is a exit. So I need to exit. So what is the ex content should be loaded? So in the ex content we should put 0x1 value to call the exit. So we have already loaded the 0x1 value into the ex, but we need to tell the CPU, right, to perform the instruction. So we put int 0x80 to state that I've given the ex value of 0x80 and I want to perform the exit instruction. So this is nothing but a system call which we're going to use continue throughout this video. Got it? We cannot use 128 or 238 or any number we want, because this is predefined into the CPU to know that we are calling the CPU. So this is called as syscall only. And for write we use I guess 4 0x4 instruction. Okay, for write. got it guys? समझ में आया सबको? Is my stream clear or my voice is clear, right? The content which you are watching now, right now, is it clear? Just tell me, is it clear? Okay, yep, okay, nice, good. So now this program, so this is your first assembly program to perform an exit instruction. Okay, so now to save this, just tap Control S and Control X in Nano. In Vim, if you are left, then just tap Escape and then all the double Q codes and all. Okay, to escape it. Now Now we need to compile this. Okay, so to compile, there is a particular command. The first command which I've explained here. So nasm, name of the compiler which we all want to use. So we are using nasm hyphen f stands for the format, the format in which we need to compile it. So we need it to compile in a elf file format of a 32-bit mode. Okay, elf file format, which is a Linux executable file. Okay, and in 32-bit format, and the name of the program. So the name of the file is mine, prgm1.asm, and the output file as in prgm1 program1.o as an object file. Okay, got this? So this is your first instruction to perform. I'll just paste it in a chat section. Okay, so this is the main command. After hitting enter, you will see I did not got any kind of errors or warning. Okay, I'll hit ls, and then we can see an object file which has been created. Now we need to link some stuffs to that particular elf file. Okay, now CPU will don't know like what exactly the code is doing, but we have given like almost 80 or 90% of code over here in that particular program, but there are still some functions which we need to link it. Okay, so and that is very mandatory to link it. So we then type a command called as ld. Okay, I'll just yeah, so ld hyphen m stands for mode elf i386. So this is nothing but a 32-bit architecture only. Okay, no need to focus on this more part. Okay, this stands for the mode. Ld means link it in the mode of this particular mode elf file, and then program1.o, the object file which we generated. Okay, and then the hyphen o to program1. So this will be a final elf file which we can execute. So I'll just give you all this in my chat section. So these are only two main commands which we need to know. Okay, nothing much. And then you hit enter, and then we get no errors, nothing at all. And then we hit ls, we can see one executable has been generated over here, program one. And if you try to run it, we get nothing. We get nothing because the program executed successfully. Okay, so now I'll try to show you all. Okay, before moving further, any doubts in this particular thing which I've explained you all? Any doubts? Just tell me if any doubts, so I can solve it. Any doubts? No doubt, it seems. Okay, 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 okay. Yeah. Now moving further, now we can see we type the name of the program and we hit enter. So we have this program didn't do anything, but it successfully got exited. Okay, so now to show you all a very proof of concept, or the proof the program really got executed, what you can do is that we're going to use Pwndbg now to debug this code. Okay, so hit enter, Pwndbg, and the name of the file which you want to debug now. We type the first command called as info functions, and we hit enter. So over here we can see some additional functions the compiler, or we can say the compiler had added to it. Okay, so these are some, the functions which we don't need to focus now, but we can see the function which we created, right? The start function, from where the execution starts, as I told you earlier. So what you can do is that do this assemble underscore start. So by now you all should know the commands, because yesterday I have also explained you all the commands, right? The info functions, the disassemble one. So I hope you all are taking note down of these commands, because these commands are very important in upcoming videos, because if you'll know this command very very fast and all, then it will be very good for you all only. Like info functions will going to display all the functions which are there into the particular binary which we have created. So these are some functions which are added by the compiler. Okay, so we don't need to focus on these functions. The function which we need to focus on this is this start function from which the code execution is going to start. Okay, now if we see, we can see our same instructions which we have written in our .asm file. Correct, right? We have wrote the same instructions over here. I'll just do program one .asm. So can you all see, guys? So this is everything same over here. Move eax 0x1 and integer 0x8, which stands for the syscall. Okay, so this is the thing why the point debug is very useful, because it gives you in the, like, exact color and the view of it. Okay, and even, like, very much stuffs. Okay, done. Now the thing is that we can see some sort of that 0 and then 0 plus 5. So these are basically, if we do this assemble and okay, yeah, if we even do this assemble, and we can see the code of that particular function, but no function contains this specified address, because these functions are been directly linked to the particular, the runtime code, which is always linking towards some sort of library which are present into the memory. Okay, so these type of contents will come in some other part of videos when you are trying to do some really some advanced stuffs of disassembling code and all. Okay, but currently we can say that no function contains specified address, so it states that, like, this function is there present, but it is trying to point to some other function we can say into the particular memory address which we don't have the current access to it. So no need to focus more on it, but yeah, it's a good question which you asked. Okay, if you do this in bro, can you start OSINT classes after finishing this course? Actually, yes, we can also do that also. We'll also start some OSINT. So everything in short which is term related to cyber security, I'm going to upload every single stuff on this channel. Okay, so make sure that you please subscribe to it, like, share, and do all the stuff. Okay, yeah, I'll also upload everything like uh, Wi-Fi pen testing, cryptography attacks, web attacks. Okay, but mostly this channel will be focused on reverse engineering only, the core part. Okay, the reverse engineering and the binary exploration part. Okay, got it? You got, like, what this mean to you? Yeah, bro, thanks. Okay, now moving forward, we can see something over here. So can you all see, this is the address. Okay, so everything which you see before this part is the address, not this. Okay, so this is just a notation, plus 0 plus 5. So I'll tell you why there is a plus 5 over here. Can you give something hint, or can you all try why there is plus 5 only over here, not plus 6? Can anyone try? Just tell me why there is plus 5 over here, or why there is no plus 1 over here. Just ask me. Can anyone tell me? Memory container, I guess. Yeah, you are almost correct. So now we can see this is the full instruction on the first memory address, right? So this is pointing to this memory instruction, move ex10. So I'll show you all why it is plus 5 only over here. So just copy this instruction. Okay, and there is a website called as we'll say, now make a note of this website. Okay, it is an disassemble x86 on online. So this is the website, the diffuse security which they provide. So over here you all can come and you all can paste your assembly code here. So I've pasted my the first instruction or the first assembly code which we see over here, right? The move eax01. So I copy this of the first memory part. I copy this part, I copy this, and I then go to browser and just paste it over here. Enter your assembly code using the Intel syntax below, and then click the architecture. So we know we are learning x86, which is a 32-bit. So click on that and click on assemble. Okay, so now it will going to give you the disassembly view over here. So can you count this? Can you count this? How many opcodes are there, or we can say how many hex are there? 1, 2, 3, 4, 5. Okay, so this move represents some of this instruction, and ex comma 01 presents some of this. So total instruction set will be the 5 instruction sets over here. Okay, because of that we can see plus 5 over here, because at this address plus 5 instruction we are trying to jump on the next instruction over here. Did you all get? We try to disassemble this particular instruction. How many instruction set it contained? So it contained the 5 instruction sets over here. Which was this? 5 sets of instructions over here. Did you all got this? This is not so important, but while doing some sort of previous engineering, you all should know why it contains only 5 over here, or why it contains only 10, 20, 30, 40. It depends upon the previous instruction sets. It totally depends upon the previous instruction size sets. Great, great, great. Okay, so so that's why we use plus 5 over here for that particular instruction set. After that we see int 0x80. Okay, so that instruction size will be containing, I guess, around not much. If you see int 80 and assemble it, we'll see only the 2 instruction sets. So further, if there were some more instructions over there, the third line will contain plus 2 because of the previous instruction size. Okay, now what we'll do is that we'll put a breakpoint at this address, and we'll see like what will going to what will be going to happen exactly into the computer memory, right? So we'll type this breakpoint star underscore start, enter. So the breakpoint will be hit it at the entry point only. So this command is very important, so make sure that how we add the breakpoints. Okay, I have given it in your chat section. So B stands for breakpoint, and there is a star symbol which we need to write, as it is an asterisk, or we can say some referencing to that particular function over here, and the name of the function where we need to enter the breakpoint. So we need a breakpoint at the particular function. Yes, this symbol, yes. So now we have already disassembled it over here. So now I'm going to run this program. When I run this, we can see I've hit the breakpoint over here, because I've added the breakpoint 1 in start. So I've hit the breakpoint, and the Pwndbg or the GDB has put a break on this particular instruction. Now we can see we are trying to move EAX1, right? And what we saw over here, yeah, over here. So what do we saw over here in the exit? Okay, yeah. So we saw in the EAX register we should enter 1 to perform an exit call. So we have done that only. We have put some EAX. We have added the we have moved the value 1. After that, if I press an instruction, okay, I guess it is NI. So NI stands for next instruction. So if I press NI, we can see I've jumped to the next instruction according to it. So can we see something int 80 and sys exit? So this is the usefulity of this Pwndbg tool. So this one is very useful because of this kind of terms, because it directly detects that what it will going to perform after this int 80. So int 80 is nothing but it is calling this CPU saying that I am having these particular registers which is containing the one value. Now the CPU knows because there are some predefined addresses over here. Oh, sorry, not addresses. The predefined syscall name which is exit. So CPU will know that if there is a one value into the EAX register, I need to perform an exit call. Okay, I am repeating it again. If there is an one value present it into an EAX register, then I need to perform an exit system call. Okay, so that is the only thing. So int 80 is nothing but just a call to CPU. Got it? In 32 bit we do int 0x80, but in 64 bit we type the term called as syscall. So in 32 bit we use this term called as int 0x80. So now we can see prior to that there is an exit call, sys exit call. So this Pwndbg has already detected what will be the further outcome of this code. Okay, so so now if I hit run, or we can say, yeah, run only, it will going to exit the code. Okay, so in this way we can see it has already exited the code successfully. Okay, I'll show you this again, and if I hit do run, we can say starting program, and this exited normally, interfering one process, so don't focus over there, but we can state that this program exited normally. Okay, did you all got what the terms doing over here, the int 80 and how the sys exit came? Come on guys, in comment section, I need your support. Any questions regarding any stuffs? Any questions? Just ask me. So no questions, right? So I can move further. Okay. Okay. Fine. 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 No. 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 See, these don't focus over here. Don't focus over here. Because you are talking about this, right? So are you talking about this or this side? Which one you are talking about? The dot asm, right? Yeah. For exit code, we need to type all these stuffs into the particular .asm file. Yeah, so that's why assembly is like, the most saluted, we can say, the like the jod language. Like, see, my thinking view is that most of the people say assembly is hard, or they say like, assembly is very tough to learn. Yes, it is tough to learn until and unless you know the basis of it. You know the how system call works, the register works, what are the contents which are being loaded into the register, and how the function flow gets into the memory. That's all what you all need to know, right? So now are you all ready to show some hello world code onto the console? Are you all ready? So I can move on further. Okay, now we're going to edit this program only. Oh, okay, what we can do is that we can just copy this stuff. Okay, just give me time. Let me install Vim, okay, because I'm more preferable to work on Vim. Okay, I'm just install Vim. Just give me some time. Just I'll install the Vim. Do you all know Vim? Just tell me one thing. Are you all aware about Vim? Anyone in the chat section? Are you all aware about Vim? So Vim is nothing but a text editor which we use, okay, just to write something into it. So it is as same as like, yeah, perfect, perfect. I use Nano mousepad. Depends, yeah. But my favorite is like Vim. So the command Vim, for others who don't know, it is just a simple text editor, okay. Okay, so it is just a simple text editor which is based on console based. So I'll say Vim and then I'll just type my name of the program. Before that, I'll touch one more file, okay, over here. Touch program 2.asm, okay. So first step is to create a file, okay. The second step is to open it into your favorite text editor. Mine is program 2.asm. Oops, sorry. And then hit enter. So this is your Vim. Now I'll paste the same code over here. Now for that we need to, now we have learned the dot text section where the code starts, right? Now to print hello world onto the screen, right, we need to store this particular string into a memory, okay. I'm getting, so we need to store this string into a memory. So for that I've already discussed to you a section. So can anybody tell what section will I use to store the data, okay? Not only initialize, to store the data. Just tell me in comment section which section. I've explained it. I've explained over here. In which section will I use to store the data? Listen very carefully. The section I need to store the data into a variable. So which section will I choose? Yeah, the start function is where we're going to, write the code. But there is one section called as section data section. Secretary, yeah, not BSS. In BSS, wait, I'll explain it. Yeah, perfect. So it is in data section. I'll explain you all over here. Is it possible to explain here on the blackboard? Okay, for you all. Yeah, I'll just close this. Do blackboard online. Okay, I'll click on this. Yeah, wait. I'm explaining. I know. First, it is very, very, frustrating and very tough. So now there is a memory, okay. There is a memory over here. So this is your memory, and there are many segments present. So in the first one segment is your dot text segment, okay, dot txt segment, which contains your code, what you write, the instruction we say, na, the move instruction, the int instruction, and the other instruction. Can you provide assembly image code? The thing is that I'm explaining that only over here. Yeah. This full live stream is dedicated to full assembly language course only, but into parts. So today we are discussing some basic stuffs about assembly, or we can say a very basic part, which is very important base, which we need to know. Okay. Now coming back, there is one section called as dot text section, which stores the code, the instruction which we type. Okay, like the code. The second instruction. Okay, the second section is your dot data section. So now this will going to store the data. So now if you all have learned Python, okay, so I hope most of you all might know Python. I'm giving the example as compared to Python only. In Python, what we do is that we store like x is equal to 10, right? So this type of variables we store 10 into the x value. So this type of functions, or we can say this type of particular thing come under the data section, because we are trying to store some data into it. So int x is equal to 10. This will state that we are trying to store 10 value into the x variable. So it will come under the data section, because I've initialized the x value, and I've given the value 10 to it. So this will come under the data section. Yeah, because this is very basics. Okay. Yeah, it is also very useful in malware development, because after all, at the end you need to know the assembly. And there is other set of called as the .bss segment, in which you store only the, not data, the initialized value. So over here we have stated that int x is equal to 10. So we have also given the value x as a 10. So this will come under the data section. But under bss segment, what type of data will come? It will come like integer x. So I have just defined this integer x into memory, but I have not not initialized any value to it. Okay. So this type of will going to come under the bss segment. We have not initialized the data into the x value, but we have just declared it over here. Or we can say we have just initialized x as an integer value, but we have not added some value to it. So that kind of data types are coming under the bss segment. हाँ, बात वैसे हिंदी में भी बात कर सकते हैं हम लोग, बट मोस्ट ऑफ द पीपल वांट मी इन इंग्लिश, दैट्स व्हाई. यू गॉट राइट, मतलब मैं क्या बोलने की कोशिश कर रहा हूँ इधर. इट्स इन डॉट डेटा सेक्शन डॉट बी एस एस. Did you all got this, the difference between these three segments in the memory? Just tell me here, please, because so this we need to know. As to, yeah, thanks, buddy, thanks. But did you all got what I'm trying to say? This all the three part. The text section will contain the code, the instruction part. The data section will going to contain the initialized data into the memory. For example, x is equal to 20 or 10. Okay, so this type of data are storing it into the dot data section. And in BSS segment, we are storing the data types which are not been initialized. They are only been just given like int x. Okay, this kind of data. आपको समझ में आया? Everyone, Soam, Safe Security Audit, Dark Side, Vinay, just tell me, did you all got na? What did I say it throughout this video? अच्छा ठीक है भाई, तेरे लिए एक्सप्लेन कर देता हूँ. ठीक है भाई, देख. टैग सेक्शन मतलब क्या होता है कि एक मेमोरी सेगमेंट में एक सेक्शन होता है विच इज़ कॉल्ड एज अ टैग सेक्शन. और उसके अंदर हम लोग जो एक्चुअल कोड है, जो असेंबली के जो इंस्ट्रक्शंस है, वो टैग्स सेक्शन के अंदर स्टोर होते हैं. और डॉट डेटा सेक्शन के अंदर क्या स्टोर होता है? द डेटा जो हम लोगों ने इनिशियलाइज किया है और उसको डिक्लेयर भी किया है. फॉर एग्जाम्पल इंट एक्स इज इक्वल टू 10. सो एक्स वैल्यू के अंदर 10 वैल्यू है. सो इट इज़ अ डेटा टाइप विच वी कैन स्टोर इट इनटू एन डॉट डेटा सेगमेंट. और डॉट पी एस एस सेगमेंट के अंदर क्या होता है? द डेटा टाइप विच वी हैव ओनली इनिशियलाइज्ड. ठीक है, उसको हम लोगों ने डिक्लेयर नहीं किया है. सो फॉर एग्जाम्पल इंट एक्स, एंड वी हैव नॉट यूज, और लाइक हम लोगों ने इसको और कहीं भी मेमोरी के अंदर हम लोगों ने इसको यूज़ नहीं किया. सो दैट काइंड ऑफ डेटा वी स्टोर इट इनटू डॉट बी एस एस सेगमेंट. समझ में आया अब तो? डार्क साइड वेरी इंपॉर्टेंट, वेरी इंपॉर्टेंट. गॉट इट ना? समझा? सो कैन आई क्लियर दिस? एवरीवन गॉट इट? थैंक्स बड़ी. या clear this up, clear this up. Now coming back over here, now we need to store it in which segment? Data segment. Okay, so we type section dot data. Okay, now after under that, just tab a, just put a spacing of dot tab, just for to look this code very beautiful. and we need to define a variable name. So now how we used to declare variables, or हम लोग variable declare करते हैं, like in C programming or Java maybe. Okay, so in Java we use like string x is equal to hello, right? So this way we try to write it into some other languages, some other, but in assembly it's not like this. Okay, so I'll explain you all how we do it in assembly. So in assembly we say, first we give the name of the variable. So in this case I will give msg, which stands for message. Okay, after that there is a term called as db, which is data bytes. Okay, there is a comment, मगर यार ये कंसेप्ट तो बिल्कुल अपोजिट है दूसरे क्या प्रूफ यस ये कंसेप्ट थोड़े अपोजिट है एज कम्पेयर टू अदर प्रोग्रामिंग लैंग्वेजेस, बिकॉज अगर आपको सी लैंग्वेज और सी प्लस प्लस आती होगी वेरी थॉरली एट अ वेरी लो लेवल, तो आपको कंसेप्ट थोड़े बहुत इजी पड़ेंगे. बट अगर आपको लाइक बहुत फिमिलर है इन लाइक पाइथन और सम हाई लेवल लाइक वेरी इजी स्टफ्स, then it is very tough for you. For that you all need to learn how the memory, how we store data exactly into memory and all. So that thing we need to know. Okay, या इट्स करेक्ट, मतलब तूने सही बोला है कि ये कंसेप्ट बिल्कुल अपोजिट है लाइक दूसरे प्रोग्रामिंग लैंग्वेजेस के मुताबिक, बिकॉज दिस इज लाइक वेरी लो लेवल स्टफ्स एंड यू नीड टू नो. ठीक है, सो नाउ ओवर हियर this is the syntax which we use, okay, to declare a string. So after that I can put like maybe world. Okay, got it. So in this way we declare a variable named as message. db stands for data bytes. Okay, getting everyone, getting everyone, right? So this stands for define byte of hello world. So msg is your variable name. ठीक है, अगर आपको सी आती भी होगी then you will be like knowing it very well. ठीक है, so variable name is msg. You can put anything over here. Okay, no doubts in that. You all can put anything like msg I've gave over here, and then followed by the name called as db, which is called as define bytes. Okay, and then in the two codes we can enter the data which we want to store. So in this case I have added the term called as hello world, which we need to print it out. Okay, everyone got how to store data in dot data section? Everyone, अरे मैं आज no worry bro, no worries, we are very friendly people over here. Okay, like yeah, अगर आपको मतलब अगर कोई भी अगर दिक्कत आ रही है, अगर आपको बहुत कुछ गाइडेंस वगैरह चाहिए, तो मैं आपको ना एक सेकंड रुक जाओ, मैं आपको एक चैट सेक्शन में मेरा ग्रुप का लिंक भेज देता हूँ, आप उधर ज्वाइन हो जाइए. ठीक है, नो डाउट्स. एवरीवन आर स्वीट ओवर हियर, दे आर फ्रॉम माय साइड ओनली. एवरीवन ओके, I'll just paste the link over here. Where is the link? Right? लाइव क्लासेस टाइम क्या है और ये रेगुलर है? लाइव क्लासेस का टाइम देख, इट डिपेंड्स अपॉन माय the friends who come to view, because on this group I post a message saying that like it depends upon you all. So अगर आप लोगों को मतलब चाहिए कि कितने टाइम पे रखे, तो मोस्टली इट विल बी एट नाइट ओनली, बिकॉज सब लोग उसी टाइम पे आराम कर रहे होते हैं ना, मतलब वो लोग घर पे होते हैं. सो यस, मोस्टली एट नाइट टाइम ही रहेगा, एंड द लाइव क्लासेस विल बी रेगुलरली अंटिल आप लोगों को ज्वाइन होना पड़ेगा. वरना ऐसा नहीं होना चाहिए कि मैंने लाइव स्ट्रीम ऑन कर दिया और आप लोग में से कोई भी नहीं है. सो इफ यू आर कमिंग रेगुलरली देन it will be better for you all and me also. Okay guys, समझा? I'm sharing the WhatsApp chat. Okay, so this is my group, so you all can join over there. Now coming back over here, did everyone got Soham, then Safe Secure, Vinay, Dark Side? You all got right? How we try to define the hello world data into the dot data section, right? You all got? Yes, sir मत बोलिए. I'm just your friend, a guide you can say. ठीक है. You all got now how these things work. Telegram channel नहीं है bro. We don't have Telegram. But we have Discord, which I've posted the link into my WhatsApp group. Okay, yes. Huh. Okay. So now we know that how we can write a code to perform an exit. For a few seconds, we'll try to forget what we have typed over here. Okay. So just forget this part. Okay. And we'll come back to this part also, because this part also plays a very crucial role in while printing the particular hello world to a screen. So now, before coming over here, now we can go to our, what we say is that the chromium syscall over here. So now as we can see over here, for so now we need to print something onto the screen, right? So there will be a term called as particular read write. So we want to write it onto the screen. So we'll search for the syscall name called as write. So I've got this syscall named as write, and we can see the NR value, which is also 4. Okay, and the EX value should contain the value of 0x4. So if the EX value contains 4 value, or the particular hex value, it will going to call to the CPU stating that we need to prepare to print something onto the console. Okay, got it? Now there are some other registers also here which we need to fulfill over here, as you can see. I'll just try to copy this if it's possible to my code segment over here. It will be not possible, I guess. Got what I am trying to say? Did you all got? When we need to write something onto the screen, we also need to set some registers over here. For example, the EBX register, the ECX register, and the EDX register. Okay, over here. The the thing is that आप विंडोज़ पे भी रन करवा सकते हो, बट विंडोज़ में कंसेप्ट थोड़े अलग है एज कम्पेयर टू दिस. ठीक है, विंडोज़ में थोड़े अलग है कंसेप्ट. हाँ, उस पर भी आऊँगा मैं, बट द रीज़न वाई एम मतलब मैं इसको लिनक्स पे इसलिए कर रहा था कि इट इज़ वेरी ओपनली सोर्स्ड एंड लाइक इट इज़ वेरी इजी टू लर्न. ओके बाय, टेक केयर कनेक्ट. हाँ, so coming back to this part, we can see the right syscall over here. So now we know, right, the first content is EAX value. So in the EAX register we need to feed up the hex 4 value, so that the CPU knows we need to write something onto the screen. Okay, so this was your first part. Now second part is called as file descriptor. So make sure आपको ये पता हो, ये अनसाइंड इंट एफ डी का मतलब होता है फाइल डिस्क्रिप्टर. सो नाउ व्हाट इज एग्जैक्टली द फाइल डिस्क्रिप्टर? सो फाइल डिस्क्रिप्टर्स, इफ आई शो you all over here, you all don't need to understand very deep in this. Okay, I'll just show you all what exactly a file descriptor is. it is used a process to identify to and open a file or just to print anything onto the console. ठीक है. So now over here we need to print something onto the screen. Okay, so whenever we need to print something onto the screen, we need to load the value of hex 1 into that particular register over here. So EBX should contain 0x1 because 0x1 will say that to CPU that we are trying to put a call of write function. Okay, and FD will contain 1, and then 1 will be going to show that we need to print something onto the screen. Okay, the third one is the character buffer. So this buffer will be the message which we need to print out. So in our case we need to print out hello world, right? So that will be going to store it into an EX register into the buffer. So that will come under the buff value. And the next register, which is called as EDX register, this will store the count. So now what are the count? The size of the hello world. So hello world will be 1 2 3 4 5 6 7 8. So the total size of that particular value we should load it into an EDX register. So did you all got at least a basic view what I'm trying to say? Did you all got what I'm trying to say? So सेफ सिक्योर विनय चैट में बताओ समझ में आया. Okay, yes. So now the first thing is that we need to load the file descriptor into the EBX register here. Before that I'm trying to load over here move. Okay, I'll just do it a bit. थोड़ा ये करूँगा मैं, जूम करूँगा, ठीक है. हाँ, तो over here first we need to move EAX the value 4 0x4. So hex 4 will state that move 0x4 to right. Okay, so now this instruction, so this is nothing but comment, bro. Okay, I've already explained. Comment it is comment. Okay, now we have loaded 4 value into the EAX. Now we need to load EBX value. So now what we need to load into the EBX, the rights is called EBX register. So we need to load a file descriptor. So in this case we need to pop it out onto the console. For that we need to load 0x1. So this you have to remember it. Okay, you have to remember it, no option for it. Move 0x1 to std out. Std out is something that is flush it out. That means that we need to print it on the console line. Okay, console. Okay, so 0x1 I'm loading it into an EBX so that I can put it onto the this console over here, the console. Okay, the next thing is that we need to load the main part comes over here. We need to load the message. So over here we can see what we need to load over here. Onto the right call const char buffer into the ECX register corresponding to this, right? So we come over here, move ECX comma, and then we load the address of this message. So now how we will do that? It is very easy. Just type the variable name MSG. Okay, message pointer to ECX register. Okay, after that what we see, the one more last register should be need to fill up. So what register we need to fill up? It is called as EDX register, and we need to feed up this size of that particular register. Okay, so now over here I'll say move EDX comma, now we need to load the size of this. So can anyone calculate the total size of this and tell me the total value of it? Anyone? Just tell me the total size of this. Just tell me the total size of this. So we can load that size over here. Just tell me in the comment. So including space. Okay, perfect, beta. Let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Perfect, yes. So we need to load level over here. So what is level? It is nothing but the move size of MSG of the message. Now there is one more instruction. So now we have already completed all these steps. We have loaded the hex value 4 for write call, file descriptor to print it in the console, the buffer we have loaded, and the size count also we have loaded, and there is nothing more to load. Okay, now can you tell me now what instruction will come next? By looking at these also you can tell. So what instruction should come next? I've already loaded all the registers, loaded all the registers. Okay, yeah, we can try. We can try. So by looking at this, what you all think? What should be the next step, or the what should be the next instruction? Exit. Yes, before exit, there is a one more syscall which should be made up, and that is called as int 0x80. So this will going to going to call. So by looking at the first argument 4, so the syscall will know I need to print something onto the console over here. So it will going to take all the values from this particular registers, and then it will going to hit CPU, and then CPU will say, okay, now we are trying to print this something onto the particular, yes, that. And then after performing that, we end up coming back over here, and then we perform a normal exit call. Okay, should we compile this now? Compile this. So to compile this, I told you there is a command is program2.asm, program2.o. Hit enter. So we can see we have got no errors, and which is a very good sign. Okay. After that, we need to do linking. Make sure we need to do a linking. So just change it to load it into the mode format of ELF i386, which is 32-bit, program2 dot object file to program2, and we hit enter. Okay, we got something over here. I guess we missed something. Let me check. Okay, let me check. Let me check. Did I missed? What did I missed? Restart not setting status. Cannot define entry symbol. The previous code was executing very perfectly, right? What happened to this? GDB, the text section, yeah, underscore start. Okay, just give me some few seconds. I'll just try to fix this. Global and underscore start. Maybe we need to copy all this stuff on top. Okay, I didn't save this file. Okay, I didn't save over here only. It is we need to save it, right? WQ. Okay, now it will work fine. Okay, it didn't work. Okay, now it worked fine because I didn't close that particular editor over here. Okay, that way it was throwing me an error. So I've done this. Now if we see over here, so we'll come back to this. Maybe it will clear. And now we can see if we see ls, we can see program 2. So what do you all think? The program will run successfully or not? Come on, guys, in chat. It will run or not? Yahoo! We did it, guys. Hello world. You all saw that? Hello world. So it got printed onto the console. But now the only thing is that it got continued the shell over here. Why? Because we did not enter or we did not put a character which will going to press enter. Arey Jai Mata Di. Okay, so can you see so we got it continue on a whole line, because after that there is a particular character which we need to put, saying that the next step will be the enter part, or we can say a ASCII code. Are you all familiar about the ASCII code? Slash n. Perfect, perfect, perfect. So we have missed a slash n over here. Okay, others are aware about it. Go over here and I'll just search for slash n ASCII value. ASCII value. So this slash n, which stands for the new line character, the ASCII value is 10, in which hex is 0x1a. So what we can do is that we can just copy this hex value and we can come it into our code and we can edit the code. Okay, so I'll just say vim program 2.asm, and over here I'll just add that particular hex value over here. Okay, so now what it will going to do is that after printing this word, it will going to also interpret this hex value as a new line character, and it will going to print that onto a new line. Okay, let's try this. Do the same process to compile the code and to run the code. Okay, we did not got it because we also missed something over here. Can anyone tell me what do we missed over here? Missed something over here. We added this value, but we missed to add some size value over here, right? For that we need to add 12 characters, because that one is also continued. So we do escape, right click, save, name it, link it, and then run it. See guys, we did it. We did it. We did it. Because we just needed to enter the size, so we just needed to change that size to the next size, because the previous one was only the level characters, but we also wanted the next character also to be loaded, which was slash n in my case. Got it? Great, and it worked. So in this way you all have created your own C your own assembly x86 instruction hello world program. Okay, so this will be a very great achievement for you if you're all learning this very first time. So now how many of you want me to debug this code into the memory and see how exactly it works? Should I debug it? It will be very fast. Should I debug? So Pwndbg program 2. Now I'm debugging this program. Okay, so now what I can do is that, yes, perfect, yeah. Now I've already loaded this into this particular, this what we say, the GNU debugger with Pwndbg extension. Now, first command. Okay, so tell me what will be my first command. Tell me the command. Command. I want it from you all. So it will be info functions. Okay, to list all the functions. So now we can see the functions called as start. So first step is disassemble underscore start. So it will disassemble, yeah, perfect, yeah, info functions and then disassemble start to see the actual code. So these are memory addresses, right? So I told you all what this instruction means and how the plus 5 came over here, because it was the size of the total instruction is plus 5 and then size of the total instruction is this plus 10, then it moves on and moves on and moves on to it. Yeah, perfectly. And then break, I guess. Yes, it's exactly correct. So now we need to put a breakpoint at the start. Okay. So we'll try to debug this code step by step. Okay. So what I'll do is that put a b star underscore start. So I've added the breakpoint over here at the start function. And then I'll type R, which stands for run. So when I hit R, I hit the breakpoint over here. Okay. Clear? Clear? So we can see the first instruction, which is that to load 4 onto the EAX. So can you all just notice over here, what is this? A syscall to write, correct? As we saw over here, the fourth value into the EAX will state CPU to call a sys write function. Yes, bro. Yeah, I'll show it. I'll show it to you. I'll just do cat. Okay. Is it okay? Is it visible to you all? Is it visible to you all now? I hope this screen is visible, right? Okay. Now the first thing is that we hit it the first breakpoint at the start. So it is a move ex4, as we have done over here. Move ex4. Okay. The move ex4, same move ex4 and we can see the register content move to ex4. Next instruction, there is a command in Pwnd debug which is called as ni. Take note down of it, ni, which is called as the next instruction. So when I press ni, it will going to jump to the next instruction. So now we can see in the EAX will loaded the 4 value because of the previous one. Okay, the next instruction is move EBX1. So over here we can see EBX1 to do std out console, or we can say to print it out to the screen. So we set it to 1. Okay, then we do again ni to see the next instruction. So now what we do over here, we try to load the pointer of message. So we just type message, move it into an ex, same into assembly code, move ex comma message. So we can see over here it is directly dereferencing the pointer to this particular hello world. Can you see this? It is trying to reference this address to the hello world. So this is the term where you need to understand like how the CPU works internally. And the next instruction, if I do ni, it tries to load the hex c value which we loaded. So now this hex c in is 12, right? So now can anyone tell me why is it hex 0c over here and it is hex 12 over here? Just tell me the difference. Let's see who can tell. In the code we can see I've loaded manually 12 value, but over here it displays me as a 0xc value. Why? Can anyone tell me why? It's a very easy term. So can anyone tell me why in the source code I've done move edx12, but in the debugger it is showing me 0xc? It is a basic question. So it's because of that the 12 is in decimal format, but in the memory it is being stored as an hex value. So if I do Python 3 over here, yeah, correct, it's in hex. So if I open Python 3 over here, and if I copy this 0x3, I convert it to integer, okay, we can see 12. So it is nothing but it is storing the data in the hex format, okay. Yeah, perfectly fine. Yeah, after that we can see syswrite. So next instruction was calling the CPU to perform the instruction. So over here it is performing the instruction of system write into the memory, syswrite, because it knows, right, it contains ex value 4, ebx value 1, ecx value message, edx value the size of the particular, the whole message. So it detects very well. So we can see hello world at that time. And if I do ni now, we can see hello world printed over here. Okay, step by step. After that we can see we are trying to move ex value 0x1 over here because we are trying to again call the exit call. But before doing exit call, we need to tell CPU, right, that we are loading one into ex. So I've done move one ex, move one ex, do ni, hit enter, and then we proceed to system call, and we do exited code with 0x1. Bro, yeah, today we have discussed the introduction to assembly assembly instructions. इन दिस ये जो वीडियो है मतलब हम लोगों ने आज एक कर रहे थे कि डिस्कस कर रहे थे अबाउट द असेंबली इंस्ट्रक्शन कैसे होते हैं एंड द प्रोग्राम हाउ वी राइट इट इन असेंबली. सो इफ़ यू आर इंटरेस्टेड, अगर आपको इंटरेस्ट है इन असेंबली और लो लेवल प्रोग्रामिंग लाइक C++, then we can say like many other stuffs which are at very low level part in the memory. So we are trying to do that kind of stuff. So yeah. Okay, yeah, I'm printing it. Okay, so I'll just do program to hello world. Yeah, yes bro, please like, share, subscribe and do all the algorithm stuffs. अगर आपको इसमें बहुत इंटरेस्ट है, अगर आपको पढ़ना है कि हम लोग एप्लीकेशन को कैसे मॉड करते हैं और इवन फर्दर हम लोग गेम्स को भी डिबग करके देखेंगे. ओके, राइट, सब्सक्राइब. Okay, so in this video we have done this today's session displaying hello world and clearing all the basic concepts of the assembly instruction. Any doubts? Any doubts? Just tell me. Any doubts? GTA San Andreas. You all want me to play GTA San Andreas? Okay, then you can just forward me the challenge. I'll try. But the thing is that I'm not very good at CTF in the web category because I'm good in these stuffs, not in web. But still, I can try it for you. Ah, bro, Som, yeah. So Som has asked a question, methodology for solving any CTF. So, the thing is that for assume if I go to CTF maybe. So my methodology is to solve while CTF is that to look. So assume if I was provided with this binary, okay, this program to binary. So there are some utilities in Linux, for an example, file. Okay, if I type file over here and if I do prgm2, so I can get some information related to this particular file. So I can see program 2 is of format in ELF, which is an executable, which is a 32-bit architecture. Intel x86, the basically the set of the processor, statically linked and not stripped. So this term I will going to explain in further upcoming videos because this concept is a very big concept. Okay, in the even in the term of reverse engineering or malware analysis, these terms are very important. What is difference between statically linked, dynamically linked, stripped binary, not stripped binary? Okay, so these terms are very important for you all. Okay, so while solving CTF, this file utility is very useful. If I have given a CTF problem of PRGM2, okay, so what I'll do is that I'll first try to find some, strings on it. So I'll just try to do strings PRGM2. Okay, so this will give me all the strings present into the particular binary. Assume there was a particular flag stored at this address, like flag, hey, you win. So that flag can be also be displayed using strings command. Okay, sometimes, so these are some sort of methodology which I use. So this is at a very basic part. For further advanced, then I'll teach it in forward in for the upcoming videos. And even I showed you all how we can use this font debug. Okay, so the full explanation of this video is in short and methodology, which is referencing, how I can solve a challenge. So it is not like a proper path or proper way. First thing is that just get some information like what exactly the particular file is doing. S trace, L trace, yes, perfect. S trace will try to detect all the signatures and all. Okay, the all the processes which it is trying to call and all. So even we can do S trace this program, this program too. So S trace is a utility. Okay, I'm not sure, but yeah, it is a utility in Linux in which we can see the what are the system calls made. So over here we can say the call made to it is a right system call, the one value, the hello world. Okay, so in this way we can trace it out like what exactly the program is trying to do, and the last system call which we made was an exit call. Okay, so these are some traces in which also we can try to find methodology in doing some reverse engineering CTFs and all, L trace and all. Yeah, I forgot. सोहम 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 समझ में आया भाई? Guys, before leaving or going further, I want to give shout out to Soham because he is the one who creates thumbnail for my YouTube channel. So yeah, shout out to Soham. He's a very best friend mine. Okay. Okay. JWT token. Blah blah blah. See, what he wants me to do is that let me see the web challenge over here. Enter a username. Not said anything. View over here also delete. Log out. So these are all post requests going onto the backend server. Log out, login, post request. Yeah, but for that we need to set up all those Bob suite and all, bro. And the thing is that I don't have Bob suite, the all the proxy browsers which I can manipulate the request. But the thing is that think if we can store some data into this web page, there will be some manipulation technique also. Like there will be some endpoints maybe, if I'm not sure. Delete zero maybe. Yeah. So we need to send it in the post format. So for that you need Bob suite, Yeah, there is a admin endpoint over here. You mean what exactly? JWT means the Java Web Token, right? But actually, sorry, bro, but I cannot help you in this because I'm not mostly into web. The reason is that only, and I sometimes hate web also. You can delete this. You can delete this. Yeah, in endpoint. No, it's bro. For that you need the Bob suite and all, which I don't have into my VM currently. Currently, this VM's setup is only for the reverse engineering and all. But still, if I'll try to solve this after stream, okay, and I'll try to find. If I get something else, then I will do. Then I will help you in this. Okay, yeah. Uh, Anything question related today? We all got right what I explained you all today. Everything done. Want face reveal? Face reveal? Face reveal? You want me to see me? Face. I hope you all got the today's session very well. If you want this, you all can share it with your friends who are interested into cybersecurity related to programming, assembly, and then many other stuffs. Want to see? Okay, guys. Any questions? No, I guess no. So we can. Bro. All are like my good friends. Hi, buddy. Hi, bro. Getting into the. I don't know, bro. It's just the power of the lightning where I put, so I can get a very bright face. Are you in college? No, bro. I'm pass out. I'm pass out. I've done my level 12th in science stream with computer science background, and then I've done my BCA, and I've done now BCA. Yeah, that's all. Graduation is completed, and 1 year I've just going. So currently I'll see to do my masters maybe, but not sure. And this all of this stuff's online only, so it's just the way you learn. Okay, everything is free on internet. I usually say to my, most of the people who come to ask me in WhatsApp DMs and all. Everything is free. The thing is that you just only need to know it how the things works. That's all. No, bro, not a BCA in cybersecurity. It was just a BCA, regular BCA which all colleges conduct, not specialized in cybersecurity. BCA, bro, like the first year they teach, the C, C++, then second year they focus on DSA, Java and all, and the third year they focus on some web development and all. Okay, that's all. Nothing big much. No, bro. Just subscribe to my channel right now. Whoever didn't subscribe, just subscribe to it. That's all. Bro is fair and handsome. Fair only. Yeah. So any questions regarding this today's uh, tutorial? Any questions regarding this today's tutorial? Yeah, you can say exactly. I started in 11 when it was time of COVID-19. I started at that time. At that time, I was exposed to the online education system. We bought a phone, the mobile phone where it all went going very fast. And the first thing it was doing some stuffs on term X and all. And after that, I was being exposed to this very huge world of cybersecurity. Yes. Okay, guys. I think it's time. It the stream is almost, I guess, 2 hours, right? Yeah, it is very large time today. Okay, guys. So we should live. Okay. No breakup story. Nothing. Nothing. Yeah. Okay, guys. Bye bye.